online yet. Today we're gonna do a little bit more programming, or learn more programming. Hopefully, we're gonna do something. That's what we're gonna do. We're gonna do something before do something. Like my Uncle Shay says, an undisputed. Every morning. All right, let me get started here. There you go. There's that. Let me get something else started here. Today we're going to start the Python essential training in LinkedIn. Really cool opportunity that LinkedIn is providing. All right.
Oh, hello. I didn't see you come in. I hear you're looking to learn Python. Well, you are in for a real treat. Not only is Python a must for web scraping, data science, web applications, I mean, the list goes on, but it's just the best introductory programming language out there. Now, sometimes introductory means oversimplified, but that's not the case with Python or this course. So if you're serious about learning Python, but don't know where to start, congratulations, you've found the right place. Hi, I'm Ryan Mitchell. I've been writing Python for over a decade, and I'll be your guide every step of the way to show you what's going on behind the scenes. You'll learn about data types and control flow, classes and object-oriented programming, parallel computing, modules, packages, and everything else you need to get coding. Yes, this is a crash course in Python and computer science, but I won't let you crash and burn. By the end of this course, you'll have a solid foundation of knowledge to build from and your own Python project to impress your friends and family with. Come on, let's get learning. Python is one of the best introductory programming languages because of its intuitive syntax, wide popularity, ease of use, and similarity to other programming languages. This makes it not only easy to learn, but easy to port your Python skills over to other languages you might program with in the future. It's an excellent gateway language. And this is why it was so important for me when designing this course to make it accessible to non-programmers. Of course, there's a wide range of skills between programmer and someone who struggles to get their printer to work. Wait a minute. I struggle to get my printer to work. Can't locate printer, but I put the internet cable in it. Calibrating ink cartridges? It's been doing this for 20 minutes now. Should I try restarting it? I don't know. It seems so busy. What is it doing? What is it thinking? On second thought, forget the printer thing. Can you use a file system? You're not intimidated by the Word file system? You know the difference between a .txt file and a Word document? Have you written formulas in Excel? That's a bit like programming, actually. Do you have an idea about how the internet works? Getting data from a remote server? Maybe you've written some HTML or you can set up your own router. You know, you should have some computer skills for this course. And if you've done programming before, great. Some of this might be review, but having knowledge about how these concepts work in other programming languages will be a big asset for this course. If you come from a front-end development background or you feel like there might be some gaps in your computer science knowledge, you've also come to the right place. This course was designed to be viewed sequentially, with each segment building on the previous one and lots of references to what we did in the past. We're going to be starting from foundations and working up to give you a strong programming background. If you really wanted to dig into Python and understand what makes it tick, you'll get out of this course what you put into it. I especially recommend that you do the challenges. I'm really excited about this challenge project that's built on throughout the course. We're taking a traditional programming teaching tool, the turtle, and flipping it on its back. You're not just programming a turtle robot that's already written for you, you're building its underlying architecture. It's like the difference between learning to drive a car and learning to rebuild the engine. By the end of this course, you should have a documented, multifunctional project that can be reused, extended by other developers, and that you can show off, post to GitHub, talk about in job interviews, whatever you want. And now let's go take a deep dive into Python. If you're serious about learning this language or learning to program, then get on that scuba gear. There's a lot of virtual paperwork with this course to help guide you on your Python journey. Let me lay it out for you. First, we have the Python reference guide. If you get lost and need to look something up, I've created a document that contains a quick reference to just about every major data type, function, and operation that we cover in this course. Keep it open as you code, and you may find that it helps things go more smoothly as you get used to working with Python. Then we have the handout. This is a list of all my favorite resources for Python learning, with a focus on where to go after this course. You can find information about advanced Python topics, as well as complementary courses that focus on the basics. Finally, those exercise files that I mentioned previously. You can find them all on GitHub or in the exercise folder, downloadable somewhere on your screen right now. Each exercise file or directory corresponds to the chapter and section number, so 0201 is the code we wrote during Chapter 2, Video 1. And if you need a bit of help finding your way, those instructions are also on the GitHub README. So that's it, the Python reference guide, the handout, and the exercise files. Now that the paperwork's out of the way, let's go gear up for Python. Computers. What goes on inside their heads? How do they think? Well, it's nothing like this. Thanks. Don't mind him. Here, I'll show you how computers think. You're probably familiar with storing files on computers. When you save a file, like a text file, it has a file name and some content, all the text inside your file. Here, this grid represents your computer's memory, where it stores files and data. And down here, I have a file name. That file name is represented in your computer's file directory, and you can think of it like the file icon that you click on. And stored with that file name is the location or address of exactly where the contents of that file are in memory. See, computers are really good at jumping straight to a specific spot in memory if they know what the address is. And that address is literally a number. Every spot in memory gets a unique number. And because the computer can jump directly to that location if it has an address, we call this address a pointer, represented by this arrow. And these pointers point to where the start of the file contents are. There's also information stored with the file name. For example, the size of the file. So this file might be 4 kilobytes long. So the computer knows that if you want to access the contents of this file, it follows the pointer to where the file starts, reads the next 4 kilobytes, and then loads all of that content for you. Now, when we write and run a computer program, what we're doing is directly interacting with the computer's memory. Programs are constantly making little bits of data, kind of like mini files. These bits of data are called variables. They have names, variable names. They point to little bits of data that we store in the computer's memory. So for example, let's create a simple program. A is equal to 2, B is equal to 3, and C is equal to A plus B. The computer will read the first line, which assigns the value 2 to the variable A. So it makes a record that says the variable name A points to the value 2, the data at this location. Then it does the same thing for B, makes a variable called B, points it to the data 3 stored at, say, this location. Then it comes to this line. The computer first calculates the value of A plus B. In order to do this, it looks at the variable A, sees its memory location, fetches the value 2, then goes to B, looks up its location, fetches the value 3, adds those two values together, and stores it in a third variable, C. Now, why do we need to know what's actually going on behind the scenes when computers are executing a program? This program is pretty straightforward. I don't need to know how the computer is storing and fetching all of this data when it runs. But consider this situation. A is equal to a list of numbers. 1, 2, 3, 4, 5. In Python, this notation with the square brackets indicates a list. You have a list of values instead of a single value. So A is equal to 1, 2, 3, 4, 5, and let's say that B is equal to A. Now what happens if we modify some value in our variable A? This right here. Let's say we change the 1 to a 6. Turns out we're modifying the value of both A and B. By saying B is equal to A, we're not duplicating A. We're literally assigning B to the same location in memory. And this concept is going to come up time and time again as we start programming. When we write programs, we're working directly with the computer's memory. We're putting data into it, we're fetching data out, we're manipulating this data. So having a mental model of what's going on behind the scenes is extremely important. All right, let's get this installation out of the way so we can get the party started. If you're on a Windows machine, keep watching. If you're on a Mac, skip to the timestamp here on the screen. All right, go, shoot, get out of here. Psst. Now that the Mac users are gone, I have to say, my favorite operating system is Windows. Macs are terrible. I don't even know why I use one. Anyway, go to python.org/downloads and download the .exe installer. Run it and make sure you click Advanced Installation. All of the boxes should be checked here. Just click Next and then check Add Python to Environment Variables. Finish the installation and you're set.
I think I already had it set up correctly, but let me make sure everything is by the book. She seems like she doesn't mess around. So she wants everything done by her direction. All right. So she wants us to go to Python. Go to download. Download. Open file. Customize. And then add Python variables. Yep, that's about it. Let's do that. It's installing right now. Setup in progress. Python 3.10.6. Setup fail. One of my issues causes setup fail. Please fix the issue. What? Another installation is already in progress. Which one? What? Which one? Oh. Customize. Okay, successful.
And you're set. You can check your installation by going to Start, CMD to open the command prompt, type Python, and you should get a Python terminal. To exit the terminal, either type quit, open parenthesis, close parenthesis, or press Ctrl-Z. Or press Ctrl-Z. Now skip to the timestamp on your screen to get the rest of the either type quit, open parenthesis. You can check your installation by going to Start, CMD to open the command prompt, type Python, and you should get a Python terminal.
Yep.
To exit the terminal, either type quit, open parenthesis, close parenthesis, or press Ctrl-Z.
Okay, done.
Now skip to the timestamp on your screen to get the rest of the instructions for both operating systems. Hey, are they gone? Okay, great. It's just us Mac users. Ugh, Windows is the worst. Anyway, you already have Python installed because Macs are the best. However, Macs come with Python 2 installed, and we do need to make sure that you have the latest version, Python 3, which means, yeah, you still have to install stuff. So go to python.org/downloads to get the installer and then run it. All of the defaults are fine. You may get the Python launcher popping up just after you install it. This is just a thin graphic interface around the Python application. We don't need it, just close it. And you should be set. Open the terminal by going to Applications, Utilities, Terminal, and check your Python installation by typing Python 3. Remember, you already have Python 2 installed, so this is just to differentiate between the two different versions of Python. You should get a Python command prompt. To exit the prompt, either type quit, open parenthesis, close parenthesis, or Control D. Okay, let's bring the Windows users back. Hello, Windows users. Come back, come back. Everyone gather around. So you both have your respective terminals and command prompts up. You should also have a program called pip. This is the package installer for Python. We're going to use it to install a piece of software called Jupyter Notebooks, and this will be used to view most of the exercise files. So type pip install notebook. If you're on a Mac, you may need to type pip3 install notebook.
Let me go to Python.
Wait a little bit, and you should have it installed.
Pip install notebook.
Then navigate to the exercise directory. The command you want to type is cd, which stands for change directory. Then documents / Python essential training, or wherever your exercise files are. On both Windows and Macs, then you type Jupyter Notebook, and you should see a browser window pop up with files on. If you're on a Mac, and this will be used to view most of the exercise files. So type pip install notebook. If you're on a Mac, you may need to type pip3 install.
I don't get it. Why is it not giving me that option? Saying syntax error, invalid syntax.
Notebook. Wait a little bit, and you should have it installed. Then
That's not how it's working for me. Oh man.
size files. So type pip install notebook.
Okay, so maybe try pip install Jupyter. Invalid syntax. What the hell is going on? What? Wow. I might have downloaded a whole matrix onto my computer right now. I feel like that guy from Mr. Robot. Downloading tokens. Installing. Let's go pip. All right, lady, bring the next challenge. Just kidding.
If you're on a Mac, you may need to type pip3 install notebook. Wait a little bit, and you should have it installed. Then navigate to the exercise directory. The command you want to type is cd, which stands for change directory. Then documents/Python essential training, or wherever your exercise files are. On both Windows and Macs, then you type Jupyter Notebook, and you should see a browser window pop up with all of the exercise files. We can open one of these, a little sneak peek here, and you should have a bunch of cells. Each cell contains a small Python program, and you can type any Python code you want in here, then click the Run button to run it. So play around with these a little if you want. We're going to be using them very heavily shortly in this course, but next we're going back to the command line. Python has been around for 30 years, and its popularity only seems to grow as it ages. Python isn't clumsy or random as JavaScript. It's an elegant language for a more civilized age. For example, the syntax, or way you write the code to call one function, is probably the same way you'd write the code to call a similar function. The designers of Python tried, and in my opinion succeeded, in keeping the language simple and consistent. And Python isn't just a programming language for beginners. I use it every day at my job to build huge, complex systems. Because when you're dealing with a lot of complexity, the last thing you want is to complicate things. And that's where Python really shines. They even have a kind of mission statement to drive this point, hidden in an Easter egg called import this. Let's go to the code. Open up any terminal and type Python to enter the Python command prompt like we did previously. You should see two greater than symbols letting you know that it's ready for a line of Python. And now we're going to type import this. Import is a good command to know. It says, go fetch me a module so I can use it, and this is the name of the module we're importing. We'll learn more about the import statements later, but if you type import this and then hit enter, you're going to get the following document printed out. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. See what I mean? Code gets complex enough on its own. I'm not going to read this whole thing, but consider this your first sort of mini challenge. Open up a terminal, type import this, and see what happens. Even if you don't fully understand every word or statement this document is making, I think you'll probably get the general sentiment. And by the way, if you go back and reread this when you've reached the end of this course, I can almost guarantee that every part of it will make perfect sense, just like Python itself. Okay, let's get warmed up. We're going to be writing our first Python program. For this, you can use any text editor you'd like. I recommend Visual Studio Code, which I'm using, or you can use something like Sublime or PyCharm. If you're
Code.visualstudio.com download. Let's do that. Oops. Oops. Sorry, I'm just looking at some work stuff right now, making sure that our happy hour is set up properly for later today. You know, critical stuff. All right, back to the code.visualstudio.com download for Windows. Why is it three different zip? What in the world is going on here? Just let it be, man. Just one button. Un botón. No joda tanto. I accept the agreement. See if there's any Easter eggs in here. If you read the whole thing. Wait a minute. To Windows Explorer file extend context menu. Directory context menu. Register code as an editor for supported files types. Add to path. Requires restart. Why? Not? a bit disappointed that this doesn't play in the background. Like, why isn't that showing? Like, it doesn't make any sense. Just fucking show. Play.
Sharp like an edge of a samurai sword, the mental blade cut through flesh and bone. Though my mind's at peace, the word out of order, missing energy, that gets colder. Oh yes, I have to find my path. No less walk on earth, water and fire. The elements compose a mandem. Opens my motor so around is amalgam. Steel packed tight in micro chip on my armor, a sign of all pro. The ultimate reward is signing out a war that odds with the times and wars with no lords. A freelancer, a battle cry of a hawk, make a dove fly in a teardrop. Wonder why I love.
Alright, choose your look. Dark theme. Why not? Sync. Hell yes. Yes. Oh. I did sign it, didn't I? Anyways. Okay. Use Vim. What do you mean? What do you mean? Oh, I see. Oh, I see. Use external open. I don't get it. I don't get it. What in the world? What in the world? GitHub is more of a pain in the ass and stuff. What is that? What is that? Symbolic links. Short versions are not exactly equivalent to. This is gonna be a journey. Okay, mother. We get it, chief. Mm, 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 mm. might work.
That might work.
All right.
All right.
We got that
We got that
for now figured
for
out.
now figured out.
Go back to my
Go
friend
back to
here,
my friend here,
Ryan Mitchell.
Ryan
She's
Mitchell.
awesome.
If you're using Windows, you can also use Notepad++, which I've used in the past. If you don't have a text editor, pause now and go get one. We'll be using them for the challenges in this course, and a text editor is an essential tool for programming in any language. So create a file called hello.py. Hello.py.
Hold on. Hello.py. I'm going to put my text editor here to the side. New file?
And a text editor is an essential tool for programming in any language. So create a file called hello.py.
We'll save this under. Let's create a new file. To save all of this under. My name. Folder called Python training. All right. Install extensions for Python. I did warn everybody. This will be very slow. So get started with Python development under the Visual Studio Code. Okay, so if you want to open or create a Python file, make sure to save it as .py. Cool. Select a Python interpreter. So run the Python. Oh, okay. All right. see if I can add the what wouldn't I be able to add? Desktop capture, command prompt, Python. Yeah, I can get this going here. Nothing like having a nice gap in the middle here to make it disturbingly awkward. I don't know why I can't scale this the way that I want to. Left and right only. All right. So we did create. We did install the Python extension. All right.
hello.py, and open it in your text editor of choice. py is the file extension for all Python files. And we're just going to type a single line of Python code that will print the text "Hello World" to the screen. So this is the print function. It takes whatever text is passed into these parentheses and just prints it out to the terminal. And notice that I've surrounded the text with these single quotes. So this isn't actually part of the text, but it tells Python, okay, I'm about to start writing some text. So these quotes are important. We can also write a comment. So let's give us a couple lines of space. Comments start with a hash, and this is just human readable text that's completely ignored by the computer when it's running the program. So comments are handy to make notes to other programmers or remind yourself what a line is doing. And I'm just going to write the comment, print "Hello World" to the terminal. Great. Now save this file, then go to the terminal or command prompt. Navigate to where your file is stored. Use the cd command, which stands for change directory. And I'm going to type cd documents github Python essential training. Now I'm not actually typing that fast, so if you don't know, you can use the tab key to autocomplete directory names. So just type cd doc tab gi tab py tab, and I can do ex tab. So just type cd doc hello world to the terminal. Great. Now save this file, then go to the terminal or command prompt. Navigate to where your file is stored. Use the cd command, which stands for change directory. And I'm going to type cd documents github Python essential training. Now I'm not actually use the cd command, which stands for change. Navigate to where your file is.
All right, command prompt.
Stored. Use the cd command, which stands for change directory. And I'm going to type cd documents github Python essential training. Now I'm not actually typing that fast, so if you don't know, you can use the tab key to autocomplete directory names. So just type cd doc tab gi tab py tab, and I can do ex tab to get to the exercise files, and then enter. So now that I'm here, I can run our hello.py.
Hold on. Give me a second. It's not working the way it should be for me. cd documents forward slash git hub forward slash Python. That's not good because it's not finding it with my tab. Training.
File with the Python command python hello.py.
Change directory. All right.
Or I can just type H and then tab, and then that auto completes. Now, previously, we've just typed Python to get to the Python command prompt. And here we're typing Python and then the name of a file. So this tells Python to run the file as a Python program. And we can see that our file is run and it prints out hello world. So congratulations, you are now a Python programmer. Go take a break, add Python to your LinkedIn skills.
All right. Patience. This is the terminal. To the terminal. Iran. There you go. Hello world. Done and done.
It takes whatever. Previously, we've just typed Python to get to the Python command prompt. And here we're typing Python and then the name of a file. So this tells Python to run the file as a Python program. And we can see that our file is run and it prints out hello world. So congratulations, you are now a Python programmer. Go take a break, add Python to your LinkedIn skills section, and join me back here as we put this into practice.
Challenge. Let's go.
All right, it's time for our very first challenge. This one is less of a programming challenge and more of a test of your ability to read documentation and follow directions. Here we have the documentation for a Python package called term color. It allows you to change the color of text printed to the terminal, like you might see with warnings or errors during installation. Not only can you change the color, but it has some attributes you can pass in, like here we have reverse and blink, and these are just optional things you can use to style the text. You can pass in whatever attributes you like, or you can remove this argument altogether. You can see here that they're setting the variable text to the output of this colored function. Then they print text in the next line. You can also use the cprint function to print the text directly without having to call print. If you scroll down here, you can see different highlight colors. Here's the whole list of attributes. Also be aware that not all these features may work with all terminals or all operating systems. So you'll have to play around with it and see what works for you. Lots to play around with and explore with this package. Now, what I want you to do is go to the website, install it with pip, and then use it to change the color of that hello world text that gets printed out. And if you're feeling ambitious, try different color changes, make a rainbow, do some ASCII art, whatever you want. Subsequent challenges will be a little more programming heavy and require less reading, but this is a great sneak peek at what day-to-day life of a programmer is often like. To be a pro, you gotta read the doc out. And if you're feeling ambitious, try different color changes, make a rainbow, do some ASCII art, whatever you want. Subsequent challenges will be a little more programming heavy and require less reading, but this is a great sneak peek at what day-to-day life of a programmer is often like. To be a pro, you gotta read the docs.
Okay. Let's see. Okay, this could be cool. Oh, the source. Continuing with Python. I would definitely do that for sure. Okay. Solution. Alrighty.
and follow directions. Here we have the documentation for a Python package called term.
Turn color. Okay.
Okay.
P or project. Import sys. Okay. Text. Colored. Hello world. Oops. Color. Text. We want red. Reverse. Blink. Reverse blink.
Sharp like an edge of a samurai sword, the mental blade cut through flesh and bone. Though my mind's at peace, the word out of order, missing in the heat. Night gets colder. Oh yes, I have to find my path. No less walk on earth, water and fire. The elements compose a magnum. Opens my motor so around is amalgam. Sharp like an edge of a samurai sword, the mental blade cut through flesh and bone. Though my mind's at peace, the word out of order, missing in the heat. Night gets colder. Oh yes, I have to find my path. No less walk on earth, water and fire. The elements compose a magnum. Opens my motor so around is amalgam. Steel peptiding micro.
Alright. Project description. Blink, reverse, blink, attributes.
Color. It allows you to change the color of text printed to the terminal, like you might see with warnings or errors during installation. Not only can you change the color, but it has some attributes you can pass in, like here we have reverse and blink, and these are just optional things you can use to style the text. You can pass in whatever attributes you like, or you can remove this argument altogether. You can see here that they're setting the variable text to the output of this colored function. Then they print text in the next line. You can also use the cprint function to print the text directly without having to call print. If you scroll down here, you can see different highlight colors, or you can remove this argument altogether. You can see here that they're setting the variable text to the output of this colored function. Then they print text in the next line. You can also use the cprint function to print the text directly without having to call print. If you scroll down here, you can see different highlight colors. Here's the whole list of attributes. Also be aware that not all these features may work with all terminals or all operating systems. So you'll have to play around with it and see what works for you.
Wait a minute. So you're saying So it's saying train module term color import color secret module not found error no module name term color module. Say one of these. No. This right here. No quick fixes available. Why is that in there then? Terminados, text wrap. see. See, this person knows. This person knows. For challenge one, just to let everyone know, if you're on Windows, this is one thing. If you're gonna teach, if it's not the same between Mac and Windows users, if you're teaching something like, for beginners, people who are learning, things like this will throw you off, and it's just unnecessary. I think. Just do a Windows based. Start off with that, and then if you want to, move to Mac or vice versa, This seems like this is a Mac based learning, but maybe it'll change later. Import. Whoa.
Variables are the most basic building block of a program. They're units that are assigned some value. For instance, I can take the variable x and assign it the value 5. The equal sign again means put the value 5 into the variable x, and so we call this equals.
Okay. Mm-hmm. It is. The printed thing is very funny. Colorama on Windows PC and try to run it with error.
I wanted to do something a little bit pretty for this challenge, so I made a rainbow. As you can see from the term color documentation, the colors that are available from term color are a little bit limited. There's no orange or purple, for example, so I made do with red, yellow, green, cyan, blue, and magenta to create a rainbow of text. I saved my file as 0106solution.py, so I can run this with python 0106solution.py. And you can see it prints out this rainbow. So nice. If we go to look at the code, I import the colored function at the top from the term color package. Then I can use that colored function. I pass in the text that I want.
Alright, so we'll go to the solution 0106. I don't get it. So where does this go? It disappears. Okay, hold on. If you're on Windows, do something differently. If you're on Windows, if you're on this, just do one. And we can, the people that want to go to those ones can go to those ones. Conda Insta, and that kind of rhyme.
Lots to play around with and explore with this package. Now, what I want you to do is go to the website, install it with pip, and then use it to change the color of that Hello World text that gets printed out. And if you're feeling ambitious, try different color changes, make a rainbow, do some ASCII art, whatever you want. Subsequent challenges will be a little more programming heavy and require less reading, but this is a great sneak peek at what day-to-day life of a programmer is often like. To be a pro, you gotta read the docs. I wanted to do something a little bit pretty for this challenge, so I made a rainbow. As you can see from the term color documentation, the colors that are available from term color are a little bit limited. There's no orange or purple, for example, so I made do with red, yellow, green, cyan, blue, and magenta to create a rainbow of text. I saved my file as 0106solution.py, so I can run this with python 0106solution.py. And you can see it prints out this rainbow. It's so nice. If we go to look at the code, I import the colored function at the top from the term color package. Then I can use that colored function. I pass in the text that I want to colorize and then the color that I want to use as a string. Then I take the output of that whole colored function there, and then I pass it to the print function in Python. Repeat this 6 times and you get a beautiful rainbow of color. So hopefully this wasn't too difficult and you had some fun writing and running your first Python program. We're going to use the term color library in the upcoming challenges. It's not just pretty, it's also useful.
Beaverton, Oregon. Yeah. No, no more questions. I've been doing really good with the exercise, or better than it was before. And you know, um, yeah, it's been going okay. I did, but I don't know if I have like for example, yesterday Debbie, the nurse, she sent me an email and is asking me for a password, but I don't understand what the for a password, and it's saying that this is different. This password is different from my normal password. I see. I see. That's what I'm gonna do then. Okay. Yeah, that'll be good. That'll give me. Yeah. Okay. I really appreciate that. That really is helpful with the whole password thing. Mm. Yeah. It's just to enter the. Okay. Yeah, that's perfect. I did with the long extension. All right. Thank you so much for the follow up. All right. You too. Bye.
Assign some value. For instance, I can take the variable x and assign it the value 5.
Ooh, I missed that.
Time for our very first challenge. This one is less of a programming challenge and more of a test of your ability to read documentation and follow directions. Here we have the documentation for a Python package called term colors. Here's the whole list of attributes. Color changes, make a rainbow, do some ASCII art. I want to to do something a little bit pretty for this challenge, so I made a rainbow. As you can see from the term color documentation, the colors that are available from term color are a little bit limited. There's no orange or purple, for example, so I made do with red, yellow, green, cyan, blue, and magenta to create a rainbow of text. I saved my file as 0106solution.py, so I can run this with python 0106solution.py. And you can see it prints out this rainbow. So nice. If we go to look at the code, I import the colored function at the top from the term color package. Then I can use that colored function. I pass in the text that I want to colorize and then the color that I want to use as a string. Then I take the output of that whole colored function there, and then I pass it to the print function in Python. Repeat this 6 times and you get a beautiful rainbow of color. So hopefully this wasn't too difficult and you had some fun writing and running your first Python program. We're going to use the term color library in the upcoming challenges.
It's a little disturbing. Knowing that and this is self-imposed frustration is, you know, this whole thing with Windows and other oh man, my hello thing has been tarnished by this 0106. Import Colorama. I don't know, it seems like we may have to skip this whole thing, 'cause there's a level of assumptions that tells me that I may not be ready for this class. Mm-mm-mm-mm. Oops. Of course, you can't find it.
It's not just pretty, it's also useful.
Alright, after this code is run, what is the value? Wow. What? What symbol do comments start with? What happens when the computer reads a comment? Like 9 in Python, that comment is
Variables are the most basic building block of a program. They're units that are assigned some value. For instance, I can take the variable x and assign it the value 5. The equal sign again means put the value 5 into the variable x, and so we call this equal sign an assignment operator. And I can run this cell in Jupyter Notebooks by pressing Shift Enter, and insert a new cell by clicking outside in the margin and typing A. In the next line, I can do print x, and we see the value 5 printed out. Of course, in Jupyter Notebooks, it will automatically display the value of the last line of each cell when you run it, so I can just type x and it displays that x. There are a few rules around variable names. They can't start with numbers, so I can do x1, well, I haven't defined x1, but I definitely can't do 1x. And you see, it's even highlighted in 2 different colors, and I get a syntax error if I run that. The syntax error occurs whenever Python can't understand what the heck you're trying to type. It doesn't understand a variable name that starts with a number. Variable names also can't have special characters except for an underscore. So you can also do uppercase or lowercase letters. Traditionally, though, in Python, variable names always start with lowercase letters. Never start a variable name with an uppercase letter because it can get confused for something called a class, which we'll discuss later. But just remember, variable names start with lowercase letters. Now, I've assigned things like 1, 2, and 5 to these variables, and these are all numbers, obviously. But we could also do something like this, name equals Ryan. And this sets the value of name to some text, which programmers call a string. And the reason this is called a string has to do with the fact that it's a string of characters. So remember how computers lay things out in memory? Each character in the string gets its own segment of memory, and the computer strings them together into these arbitrarily large strings. If you ever forget the name of a type of variable, there's a handy function for that. You can just use this Python function called type, give it the name of your variable, and it returns string, or str for string. We could also give it the x that we did, and we get int for integer. There are a lot of types of variables in Python, so let's just go over a few basic ones. Obviously, there are numbers. Programmers call whole numbers like 1 and 2 and 3 integers, or in Python, an int. But not all numbers are whole numbers. We also have decimals or floats. So 1.5, that's a float. Why are they called floats? Well, I can write a float like this. Most of the information is on the right-hand side of the decimal place. But I could also write a float like this, 0.9. Most of the information is on the left of the number. Remember again how computers store things in memory. They also have to record where that decimal place is in the number, and they don't know whether all the information is going to be on the left or the right. So that decimal place kind of floats around. That's why it's called a float. Also, for any complex math applications, we can use complex numbers. Honestly, I've only used these a couple times in my career, but as one of the basic number types in Python, they're worth knowing about. So remember back from algebra, imaginary numbers are the square root of negative numbers and usually represented by the letter I. However, in Python, they use the notation common in engineering, which is j. So we can write, let's look at the type of 2j. It's a complex number. We can also do math with these. So 1j times 1j, that asterisk is multiplication. That gives us -1 plus 0j, or -1. So remember, I times I, or 1j times 1j, is -1. I mentioned strings a little bit earlier, but let's go over some fun things to do with them. So strings are declared with single quotes, or with double quotes. You can also use double quotes. It's the popular style in Python these days, so that's what we'll be doing throughout this course. So I can also add strings together. So string 1 plus string 2 sticks the 2 strings together, or as programmers say, concatenates the strings. And something interesting I can do is concatenate 2 strings that are numbers. So what's string 1 plus string 1? If you thought it was 2, you'd be very disappointed. It's actually 11, the string 11. Remember, strings are not numbers. So Python is just sticking these two strings together, and that gives us the string 11. What happens if we do string 1 plus 1, so a string plus a number? Just kidding. Your computer's not going to explode. Python just prints out a type error. It can only concatenate string, not int, to string. So when you get errors in Python, it's important to read them and understand what's going on. The error will usually tell you what you're doing wrong. Finally, let's look at Booleans. So Booleans are true and false values. Note that they start with a capital letter here. If I try to do a lowercase true, it tries to interpret this as a variable name and says that it's not defined. However, if you want to be very confusing, you can write a little program like this. So how are Booleans usually used in programming? Well, they're not usually used directly by typing true and false explicitly, but we usually get them as the result of statements like this one. Now remember, a single equal sign, if we scroll up, this is an assignment operator. The double equal sign is a statement. It's saying 1 is equal to 1, and we get back true. We could also do 1 is equal to 2, which is of course false. This double equals is a comparison operator. So this is a comparison operator. We're comparing two values versus the assignment operator where we're assigning a value into a variable. So this was a lot of information from one video. Don't worry if you don't have everything memorized. You can't write a program without variables, and so we're going to be revisiting these concepts throughout the course. We just looked at simple variables that were assigned a single value. But a single value like 5 or true or false is only so useful. We might want to have an array of values in a variable. So Python has something called data structures. And the first one we're going to look at is a list. So if we say my list is equal to open square bracket, close square bracket, this defines an empty list. And then we can add some values to it with commas. So this is a list of length 4. And if we print my list, we see that printed out there. Now we can put really anything we want in a list. So you could have list of strings, and this is a list of length 3 containing 3 different strings. All right, we could also have a list of mixed strings and integers and booleans and whatever we want. False. We can even throw in another list in there. In fact, you can have a list of lists. Just do that. Okay, so we have a list of lists, and we can put values inside some of these inner lists and put a false and a true, whatever we want. So there's a nifty function you have with lists called length. Okay, so if I look at the length of my list, I get 3. And so that's this list here. And even though we have lists of lists inside of here, the length of this list is 3 because there are 3 lists inside of it. So it has a length of 3. And let's look at a couple data structures that are very similar to lists. And the first of these is called sets. So let's talk about sets. A set is almost identical to a list, except that all of the elements in it have to be unique. So we can define a set with curly brackets like this. And let's put some elements in it. And if we print it out, my set, we see those all get printed out with the curly brackets that indicate that it's a set. We can also call the type function. Of course, it's a set. And we can also use the length function. So it has a length of 5. There are 5 elements in the set. Now let's make a set equal to 1, 1, 1, 2, 2, and look at the length of that. The length is 2. Remember how I said that every element in a set needs to be unique? So when you add the elements 1 and 1 to the set, it just takes in 1, doesn't add the second one. And then similarly, it discards that second 2. So if we print my set, there's only those 2 elements there. And the other thing to know is that the order of elements in a list is very important. So I can say 1, 2 equals 1 comma 2, and that's true. So these are two lists. These are two equal lists. But if I do that, it's false because the order of elements in the second list is different. But if I do this with a set, 2 comma 1, it's true. The order of elements in sets does not matter. I can even put a 3 in here. It's still true. And I can do a couple more 1s. Still true. These are the same sets. Now let's look at tuples. So tuples are declared with parentheses, like this. 1, 2, 3. And tuples are very similar to lists. They have a length. You can use the length function. Let's call that my tuple singular. And length of my tuple is, of course, 3. The order also matters with tuples. So 1 comma 2 is not going to be equal to 2 comma 1. That's false. The difference with tuples is that I can't append or add things to tuples. So if I do my list dot append 4 and print my list, we're using that list from up top, it adds the 4 to it. And I can append a 6, adds that on, whatever I want. But if I call my tuple dot append 4, tuple object has no attribute append. You cannot modify tuples. We're going to learn a lot of ways to modify the values in lists, but once a tuple is declared, you can't change it, add to it, change any of the values in it. It has to remain the same. So why would you use tuples? Well, remember back to how computers store lists in memory. If the computer knows that you can potentially add things onto a list, that list is going to increase in size. And so Python will try and sort of pre-allocate a larger chunk of memory for that list than it needs in the moment. With tuples, Python knows that you're never going to be able to add to them. So it uses only exactly the amount of memory it needs to store tuples. So tuples are often used to, say, store XY coordinate pairs. You could store many thousands or millions of XY coordinate pair tuples much more efficiently in memory than you could with lists. All right, and the final data structure we're going to look at is the dictionary. And this is very different than the previous three, but you'll use dictionaries a lot. So remember dictionaries from the real world? Big books, you look up words in them. And when you look a word up, you get back a definition of that word. And in Python, dictionaries are kind of like that. So let's make a dictionary here. Apple is going to be a red fruit. Bear is going to be a scary animal. Okay, and let's use my dictionary and look up the definition of apple. Okay, so you can access the data in dictionaries like this, and you see it prints out the value of red fruit. This is the definition or the value that you get back for what we call the key. And dictionaries are declared with these curly brackets, a bit like sets, and you have these key value pairs inside of them. The keys in dictionaries also have to be unique. So if we take this dictionary and say add a second definition to it, sometimes a green fruit, and then we call my dictionary and get the definition for apple, it actually just takes that second definition. So this is kind of interesting because sets also have to have unique values. The order with sets, both sets and dictionaries, doesn't matter. You can put these keys in any order you want. So I've always thought that dictionaries were a little bit like sets, and of course they're both defined with the curly brackets. We're going to be using all of these data structures a lot throughout this course. This is just a quick introduction, so have fun, play around with these, and I'll see you later. Operators perform operations on variables and values. Where variables are the data, operators are the instructions as to what to do with that data. The most obvious type of operator you're probably familiar with is the arithmetic operator. They do math. So we've seen the addition operator already. 1 plus 1 is 2. Let's go over a few other arithmetic operators that Python makes available for us. This is the multiplication operator. It's an asterisk. It obviously multiplies numbers together. Pretty straightforward. And this is the exponent. So this is 5 raised to the second power, which is 25. We can do division with a forward slash, so 20 divided by 5 is 4. And notice that this returns a float value rather than an integer. Anytime you do division, you're going to get a float or a decimal value back. That's because you might not always get a whole number as the result of that division. So if I do 20 divided by 6, it's obviously a float, right? So these math operations are all pretty straightforward, but there's one that's really kind of specific to programming that we need to cover, and that's the modulus operator. The modulus operator gives you the remainder after any division. For example, if I do 20 modulus 6, I get 2 back because 20 divided by 6 is 18 with a remainder of 2. And this operation comes up a lot in programming. Personally, I use it all the time, and we'll see why in the video on mathematical operators a little later in this course. There are a couple of basic operations we can do with strings as well. So I mentioned string concatenation earlier, string 1 plus string 2. And so this is the addition operator using strings, and it just concatenates or sticks them together. So you can also do string multiplication. String 1 multiplied by 4, and that repeats that string 4 times. So with the concatenation or the addition with strings, obviously this takes a string and a string. It operates on 2 strings. This operates on a string or a number. If I do, string plus 4, I'm going to get an error there. So just make sure you pay attention to the types of the variables you're working with, and remember this one because it's a really handy trick if you want to do a lot of repeated strings. All right, so let's look at another set of operators. These are comparison operators, logical operators, identity operators, and membership operators. Okay, it sounds like a lot, but they're all really straightforward, and you don't have to remember which group each operator is in. These operators all evaluate 2 variables or values and produce a Boolean, true or false. The first is the comparison operator, which we've already seen. So true is equal to true. That's the double equal sign is the comparison operator. You can also do less than. 4 is less than 5. You can do less than or equals to. All right, let's do 5 is less than equals to 5. That's true. And of course you can do the greater than. 5 is greater than 2. And 5 is greater than or equal to 2. So all pretty straightforward. Then let's look at the logical operators. Logical operators are actually just plain English words. They operate on Booleans. There are 3 logical operators, and, or, and not. With the and operator, both sides have to be true, evaluate to true. So true and true. If I did true and false, that's false. Remember, this has to be true and that has to be true. The other one is the or operator. So true or false. This side or that side. So the only situation where this evaluates to false is if I do false or false. Then the not operator. This is a little bit special. It only operates on one thing at a time and simply flips the Boolean that it's operating on. So if I say not true, that's false. If something is not true, it's false. If something is not false, it's true. It just flips whatever this variable is. So membership operators are also nice English words. And the 2 membership operators are in and not in. So you can write 1 in 1, 2, 3, 4, 5, and you get true. You can say 10 in 1, 2, 3, 4, 5, and that's obviously false. 10 does not appear in this list. But if I say 10 not in 1, 2, 3, 4, 5, that's true. You can also do this with strings. So cat in my pet cat. The string cat appears in this string. Of course, keep in mind that the word cat is also in catatonic. So be careful when you're using this trick in Python when you're dealing with strings. Of course, if I put not in here, as you can imagine, that simply flips the value. All right, so that was a whirlwind through the concept of operators. If you didn't quite catch everything, don't worry. We'll be circling back around and putting this to practice later on. This is where programming really starts to get powerful. There are three main types of control flow that we're going to cover. And the first of these is the if statement. So this is pretty straightforward. A equals true.
Oh,
If
I need to
A,
do my push-ups too.
print, it is
100
true.
push-ups a day.
And if I change A to false, nothing prints out. So notice that I've indented in the line after my if statement here. So this colon followed by an indent means that everything indented under this line belongs under the if statement. It sort of belongs to the if statement. So any indented code is executed only if A is true. I could add another indented print line. Also print this. And now both of these lines belong under the if statement. We say we're in the if block. A block of code is these indented lines under here. Now I could also outdent and add another line. Always print this. We see that even if A is false, this gets printed out because it doesn't belong to this
80
if
more
statement here.
push-ups.
And of course, if A is true, all three of these lines get printed.
To
I can
go.
also add an else statement here. Else
Nico.
print it is false. Okay. So if A is true, do this block. Otherwise, do this block. So the indenting in Python is very important here. It really controls the structure of your program. Things can really get indented quite a bit. Like, let's bring this down into a new cell here. And let's add another variable. Let's call it B. And we can actually indent under here and make a completely new block. If B, both are true. And if we run this, we see both are true printed out. We can even add a third variable, C, and just keep indenting if C, print all three are true. And you see that gets printed out. Of course, if we set any of these to false along the way, we never reach that line there. So you can see how this could start to get a little bit ridiculous. In order to prevent excessive indenting and convoluted structures like this, Python has another tool, and that's called the loop. Let's look at the for loop. So for loops iterate over, well, what we call in Python iterables. A list is a type of iterable, so we can make a list like 1, 2, 3, 4, 5. For item in my list, my iterable list A, print item. Now keep in mind that the in here is not the same as we did previously. So for in A, that gives us back a Boolean that says that yes, it is true that the number 4 is in this list of items here. This in is actually very different, and it's just part of the for loop syntax. You say for each item in the list, do something with that item. The other thing to note is that the item here is just a variable that we're declaring in this line. You could use anything in here. For B in A, for number in A. You get to name it in that for loop. Just remember to change the variable name inside your for loop, otherwise you'll get an error. A while loop is similar to a for loop, except that it doesn't iterate over items in a list. It just keeps looping until the Boolean you pass is false. So let's say A is equal to 0, while A is less than 5, print A. Now here's a very important line. A is equal to A plus 1. And we see that we get basically the same results as the for loop. We're starting with 0, of course. But it's very important that you have this line in here because without it, the loop would never end. And we'd be printing the number 0 forever. More than one programmer has made that mistake. So generally you want to use while loops when conditions are changing or that are being impacted by the block under the while loop. A function can be thought of as a machine, like this toaster. We put in bread, and we get out toast. It applies the toasting function to the bread. What if I put in these breakfast pastries? Well, it's not bread, but a toaster can still apply the toasting function to it. Look, it returns toasted breakfast pastries. What if I put in this brick? or 3 bricks? This gallon of milk? If only this toaster were better programmed to accommodate these inputs. Let's go to the code. We've seen a few functions so far. So print hello world, first one we saw. And print is a function. It has a function name, print. It has these parentheses where you can stick all of your inputs or arguments. This is like bread going into the toaster. And the argument for here is hello world. And in Python, we can even define our own functions. It's a bit like defining variables. The function name rules are the same as the rules for variable names. Start with a lowercase letter. You can't start with a number, etc. But we use a special keyword called def, which stands for definition. So we can make a function def multiply by 3. And then we write our parentheses, put any variable names for arguments that we want. And this is just going to take one variable called val for value. Then we add a colon. And just like with the for and while loops, this colon means that we need to indent the next line and start our block of code. So we're going to return 3 times the value. I'm going to use another keyword here called return. So functions usually return things. And what we're returning is 3 times the value that we passed into the function. So now we can call this function. Multiply by 3, 4. And the value that gets returned is 12. We could change this a bit and make a function with 2 arguments. Def multiply val1 and val2. And we're going to return val1 times val2. And then if we call it multiply 3, 4, again, the returned value is 12. Now, functions don't always necessarily have to return anything. For instance, we can make a function that mutates or changes a value. So let's define a list A and a function append for my list. My list.append for. And then we're going to call this on our variable A and then print A. We see that the number 4 has been added to the end of this list. This function didn't return anything, but it did, perform a function. This is a bit like bread going into the toaster and leaving the toast there for a while for someone to go and collect later. You don't always want it popped back up at you. If we look at the print function, we also see that it doesn't return anything. So let me just copy this. And it prints something to the screen, but it's not popping anything back at you. So what if we printed the returned value of the print function? You see, it prints none. So the print function actually returns none. And none is a special Python keyword, like null or undefined in many other languages. It doesn't really have a value. It represents the absence of value. It has its own type, the none type. And in general, you want to be really careful when using none. If you think you're getting a value and you try to operate on it, like none plus 1, you're going to have a really bad time. Oh, my gallon of milk is done. We already talked about a toaster function, but what if we want to make a whole kitchen? A kitchen has many abilities: toast, bake, microwave, wash dishes, and of course, the all-important coffee maker. These various kitchen appliances have settings: the knob on the toaster, the power setting of the microwave. The dishwasher itself has different modes and multiple functions that can apply to dishes. And sure, we could make a whole bunch of functions and variables and throw them in a file somewhere. But what if we want 2 separate kitchens with different abilities and sets of appliances? What if we want to make a whole house with a kitchen, a laundry room, a bathroom, multiple houses, maybe one with no laundry room that has to outsource its laundry to a laundromat? You can imagine how these systems would lead to dozens or hundreds of functions, thousands of variables, code that gets long and unmanageable pretty quickly. Fortunately, programmers have invented a tool to deal with situations like this: the class. A Python class is a great way to keep related collections of functions and attributes labeled and organized. Let's go to the code. The classic way to demonstrate classes in programming is by using animals. So let's make a class called dog. So we need to define a class with a name, and you get to use an uppercase letter for class names. This is what makes them different from variable and function names. Classes usually start with uppercase letters. And because we've typed a colon, this indicates that we're going to indent to the next line. And everything inside this indent is going to be our class definition. Now we can start defining all of the functions and attributes that a dog has. And the first function that we want to define is a special one, the init function. Init stands for initialization, and this function is called whenever an instance of the class dog is created. It has 2 underscores on either side. And this is a special Python defined thing, so the computer will recognize this as the initialization function. Then we're going to pass in a variable called self. This variable is the specific instance of the dog class after we've initialized it. And we'll just watch. This is going to make more sense in a minute. We're going to define a couple attributes and functions in here. We want to make a dog with 4 legs and a name, and we'll call it Rover. So name is equal to Rover, and self.legs equals 4. We're also going to make a function called speak that prints out bark. Print bark. Notice that I passed the self variable to the speak function. This means I have access to any of the attributes or functions in this class. For instance, I could do this, self.name plus says bark. And this will concatenate the dog's name with this string here. Now let's use this class. So let's just run that, and then my dog is equal to dog. So my dog is equal to an instance, a newly created instance of the class dog. Now this syntax with the parentheses makes it look a little like a function, but dog is a class, not a function. And this is why it's important to adhere to the Python convention of keeping variables and function names lowercase, and only class names are capitalized so that you can tell the difference between the two. When we do this, the initialization function gets called, and we get an instance of our dog class returned. We can create another dog. It's equal to dog. Okay, so now we have my dog and another dog. So let's do my dog dot speak. Rover says bark, and another dog dot speak. It's always possible to have 2 dogs named Rover. It's a very common name, but this starts to get a little bit confusing. What if we want to give dogs different names? And we want to maybe provide a name when we initialize the dog. All we have to do is this. Pass in a name variable and say self.name is equal to name. Then when we create each dog, we pass the name in. Rover and Fluffy. Rover says bark and Fluffy says bark. Much better. Notice that the speak function, when you call it, it looks like it doesn't have any arguments. There's nothing being passed in these parentheses. But if we look at the function definition in the class, it does have one argument, self. And the way Python works is that if you have a class instance, like these 2 things are instances of the class dog, and you use the dot function syntax, it acts like your instance was actually passed in as the first variable of this function. So this self variable here is literally the instance of the class that the function was called on. So if you've heard of the term object-oriented programming before, this is what it is. These class instances are also called objects. These are dog objects. The variables inside these classes are called attributes, attributes of the objects. The functions in here are called methods, and you can call them class methods. We say that the dog object has the method speak. So this was a very brief introduction to some of the concepts and terminology of object-oriented programming, but I'm going to be showing off really how powerful they can be later on. I am very excited about this challenge because it's introducing a project that we're going to be carrying forward through the rest of this course. By the end, you should have something really cool that you can commit to GitHub, showcase in a portfolio, and really make it your own. For these challenges, I encourage you to think outside the box and use each challenge as a starting point for what you could do rather than just another box to check. Now, obviously, if you're not inspired by a particular challenge, just get her done. But I want you to think of this project as your own thing, and I really hope that you get as into it as I did. So without much further ado, introducing the latest in graphics technology, the Terminal Scribe. It draws a dot on your screen. And this dot can do anything: left, right, up, down. And okay, well, that's all it really does right now. But let's take a look at the code. It has two classes in it: the canvas on which the Terminal Scribe draws, and the Terminal Scribe itself. I have some code in here to start, which gives you a Terminal Scribe instance that you can use. So, your mission: create a function that draws a square. Pass in, as an argument, the size of the square. So if I pass in 5, it will draw a square that's 5 units wide and 5 units tall. Could you draw other shapes? Maybe. Could you create a function that draws a square. Pass in, as an argument, the size of the square. So if I pass in 5, it will draw a square that's 5 units wide and 5 units tall. Could you draw other shapes? Maybe. Could you make a draw square method on the Terminal Scribe class itself? Sure. Give it a go.
All right, so this is 2.1234567. Challenge. I thought we did that. Hey, Elvin. All right. And the goal is to run scribe.py. So we gotta create run scribe.py. Alright, so let's import class canvas. Class canvas. So we're going to create a class called canvas. I'm going to give it a definition. Self, width, height. So self, x is your width, height. I can dig it. Class canvas. Okay. And if everything goes well, there you go. Give it a definition. Start with all of this. Okay. I'm still getting that. No term color. I'm missing module source. This is going to take me back to where we were earlier. I'm not sure. There's some assumptions here with these videos that are yeah, I'm gonna take a little break and reconvene because this is go get some lunch. It's 1:23 p.m. All right, I will get back on later. This has been a very slow day for programming learning, for me at least. Yeah. All right, I'll be